one of the subjects in this semester is this one. And what are the prerequisites for this subject are mathematics and physics. You might have studied about the physics in intermediate as well as the first year. Those prerequisites may be required for understanding these concepts. And what is this course objectives? So as you are studying this subject, you should know the course objectives. So the objective of this subject is introduce the basic concepts of electrical engineering parameters and quantities. So the parameters are voltage, current, power, and energy. These are the quantities and parameters of this electrical engineering. That is the first course objective. Second one is analyze AC and DC circuits. So in electrical engineering, there are two types of the supply. One is AC supply, another one is DC supply. So do you have idea of this AC supply? From the switchboard, you can directly get the AC supply, right? That is the source of AC. And can you guess what is the source of the DC here? Anybody can guess? DC source is battery. Best example is battery. Okay. So we are going to analyze this AC and DC circuits. Okay. What do you mean by a circuit here? It is the combination of the sources and elements. We will discuss one by one later in the next classes. That is the second course object. Third one is understand the construction, operation, and analysis of transformers and DC machines. Okay. So I think you might have seen the transformer somewhere. What is the purpose of the transformer? You might have studied about this transformer in 10th class also. Can anybody tell me what do you mean by a transformer? It is a static device which is used to step up and step down the voltages whenever it is required. Okay. So we are going to understand the construction. Inside a transformer, what are the different parts which are available in the transformer, and all those things we are going to discuss. That is one of the course objectives. And another one is DC machines. So these DC machines are two types. One is generator, another one is motor. So generator is an electric machine which can generate electrical energy by using the mechanical energy. So it can convert mechanical energy into electrical energy. Okay. And what do you mean by a motor here? Which converts electrical energy into mechanical energy. Electrical to mechanical. Can you guess what is the best example for the motor? Day-to-day life, which you can see. Please respond on it. Every day we can see the applications of the motor in day-to-day life. Best example is a fan. It is taking an electrical energy and it is converted into a mechanical energy. Other than fan, can anybody tell me the motor applications? Where can you see the motor? Please. Lifts, escalators, and all appliances, you can see the motor application. Okay. Next objective is introduce the operation of measuring instruments. I already said that there are electrical quantities like voltage, current. So if you want to measure the voltage and current, we require some measuring instruments. Those are voltmeters, ammeters. So voltmeter is a device which is used to measure the voltage. Ammeter is an instrument which can use it to measure the current. And it is used to measure the current. So these are the course objectives. That is the purpose of the studying this course here. Now, what about the course outcomes here? After completion of this course, every student should understand the basics of electrical circuits and parameters, operations of transformers in the energy conversion process and electromechanical energy conversion. That is the course outcomes. Am I audible to everyone, please?
Yes, sir.
Next, analyze the DC machines. So just now I told these DC machines are again two types, generators and motors. We are going to analyze those machines. We are able to analyze those machines after completion of this course. Third outcome is measuring instruments should be able to use the voltmeter, ammeter and wattmeter. So the purpose of the wattmeter is used to measure the power for measuring the electrical quantities. Okay. And last one is to apply these concepts of electrical engineering to design. As you are a civil engineer, if you want give a design for a particular house and all those things, compulsory you should use these concepts where the switchboard is located and where the motor should be located, all those things should be use these concepts for your civil engineering purpose. And you should analyze the basic electrical circuits and machinery. So these are the course outcomes and course objectives. Yeah. So this is unit 1. This is introduction to electrical engineering. In this we are going to study about the Ohm's law. So you might have studied about the Ohm's law in 10th class also. And what is the Ohm's law, statement of the Ohm's law, and what is the limitation of the Ohm's law. All those things we are going to discuss. And basic circuit components here. Suppose if you take any electrical circuits, there are some basic concepts. Resistor, inductor and capacitors will be there, and voltage source and current source. These are the main basic components of any circuit. So I will tell what is a circuit and network later. The circuit is consisting of resistor, inductor, capacitor, voltage source and current source. After that we will discuss about Kirchhoff's laws. So there are two laws for Kirchhoff. One is Kirchhoff current law, that is known as a KCL, Kirchhoff voltage law. So these things also we might have studied about in the earlier classes, and some simple problems. So did you study or not? Please respond now. Did you study about the KCL and KVL in earlier classes?
Yes, sir.
Please. Can anybody tell me the statement? If you are able to recollect those things, please respond. Okay. Suppose if you take a Kirchhoff voltage law, the algebraic sum of all voltages around a closed loop equal to 0. Around a closed loop equal to 0, it can be stated like that. If you take a KCL, statement, algebraic sum of all currents which are entering or leaving at a node is equal to 0. So these things you might have studied at code in the earlier process. From here onwards, the things will be different. So you might have studied about the Ohm's law, KCL, KVL, about the resistor, inductor, and capacitor. And the next concepts are network analysis. Some basic definitions we are going to study about. Some basic definitions means what do you mean by a voltage? Okay, what do you mean by a voltage? Next, what is a current? What is a power and what is energy? All those basics. And other than these basics, related to some circuit concepts, what is a node? What is a loop? And what is a circuit? What is a branch? What is a mesh? All those basics we require to understand these concepts. Types of elements here. So types of elements based on the property of particular resistor, inductor, and capacitors, the elements are going to be categorized. Elements are nothing but resistor, inductor, capacitor, voltage source, and current source. Voltage, these are called elements, circuit elements. Okay, based on the property of those elements, that is, those elements will be categorized based on the properties and the types of the sources here. Okay, so based on the property of the sources also, the sources are going to be classified. We are going to discuss about those things also. Resistive network, the circuit is having only a resistive element, resistor, that is known as a resistive network. Inductive networks, okay, a combination of inductors are connected in parallel, those are said to be inductive networks. Capacitive networks, so these elements can be connected in different ways. Those things can be treated as a capacitive circuits, inductive circuit, and all those things. And these elements may be connected in series or parallel. Those are known as series and parallel. And you know, and this is another resistor R2. Okay, how can you say these two resistors are connected in series? Means the second end of this resistor, let us take this is A and B. End's name is A and B. This end's name is C and D. If the B and C are connected like this, yeah, then we can say these elements are connected in. Please tell me, these elements are connected in
series connection. Series.
Yeah, series connection. This is series connection. Suppose and some voltage source is applied to these elements. So we will discuss in detail about these elements. And suppose if R1 is here and R2 is here, if these two elements are connected like this, and these two elements are connected to the source like this, these two elements are connected, you can say these two elements are connected in parallel. Likewise, we are going to discuss about series and parallel circuits. Circuit is defined as it is the combination of a voltage source. The voltage source can be represented like this, and some elements. This is known as a circuit. Voltage source V and R1, R2. It is an interconnection of all elements. It is known as a circuit. Okay? So that is known as a series and parallel circuit. And star delta to star transformation. Sometimes these elements may not be connected in series and parallel. Then those connections will be known as a star connection. Suppose, let us take, this is resistor R1, this is resistor R2, and this is resistor R2. See, if the elements are connected in this fashion, this is known as a star fashion. We can say the elements are connected in star fashion. We can convert this star fashion into delta fashion for the purpose of simplicity. So you can say this is R1, R2, R2. That means we can rearrange these resistances into, this is a delta fashion connection. So we can say this is star to delta. And the values of these resistance may be different, okay, but the current which is passing through these elements is same. So in the circuits, we will discuss clearly about this star and delta. Here, sometimes you need to convert this star to delta and delta to star for the purpose of finding current and voltage in a particular circuit in easier way. For that purpose, we require a star to delta and delta to star transformation. Okay, no? That is about star to delta, delta to star transformation. Later, we will discuss about the network theorems. The purpose of these theorems is actually to calculate the current and voltage, power and energy in a particular circuit. The Ohm's law, KCL and KVL are required, is enough, but some of the circuit may be complicated. At that time, we will use these particular theorems to simplify the circuit or to calculate the current and voltage, I and V. I and V means I is for current, V is for voltage. So the purpose of this theorem is, if the circuit is somewhat complex, we will be using these theorems to calculate the voltage and current. That is the purpose of the network theorems. In that theorems, we have superposition theorem, Thevenin's theorem, maximum power transfer theorem. So 4 theorems are there. There are 4 types of the theorems. All these theorems are used to calculate voltage in a particular circuit and current in a particular circuit, and power also. Okay. So by using these theorems, we can calculate this voltage, current and power, and some simple problems. See, this is part of this principles of electrical engineering, because without these basics, you can't understand the remaining concepts here. All these second unit concepts are depending upon this first unit concept. Each and every unit is interlinking. If you miss one part of this concept, you may not understand the next one. So all these concepts are interlinking. So I suggest you that don't absent for the classes, be regular to the classes, and you should maintain a separate notebook and write the running notes possible, write the running notes, or once I post the recorded classes in Google Classroom, then you can download, and after downloading, by listening the class, you can prepare your notes. Okay. So in that way also you can maintain the separate notebook. So I will check the notes every week. Okay. Every week I will check the notes. Each and every person I will ask at the time how to show the notebook. And that notebook, each and every concept should be there. Because the concepts are like that. To follow these concepts, the subject is very, very simple. If you don't follow, it is very difficult. Okay. These are the basic concepts of unit 1. Next, come to the unit 2, alternating quantities. And this total first unit is related to the DC circuits. It is also known as a DC circuits. Because here we are using the DC supply for this resistor, inductor and capacitor. The supply is itself DC. How to differentiate DC and AC means the voltage source can be represented as circle, inside a circle, plus and minus. It is the symbolic representation of voltage source. This is a DC supply. We DC antaru. This is AC. Inside a circle, there is a sine wave, which is known as a VAC. The first unit is related to DC, and the second unit is related to AC concepts. alternating quantities. In that, we are going to discuss about principles of AC voltages, waveforms. Just I will read out these concepts because you don't know all those things. Even though if I explain, you may not follow. Based on basic definitions, what is a waveform? What is a cycle? That means waveform cycle. What is the frequency? What is the average value? What is the RMS? Root mean square value. And what is the average value of alternating current and voltage? Next, what is a form factor and what is a peak factor? What is a phasor representation of these quantities? What is a J factor or J operator? And what is a phasor algebra? Analysis of AC circuits with a single basic network element and single phase series circuits. Single phase series circuits. This is about the second unit. If you come to the third unit, transfer. These are related to some circuits concepts. And if you see from third unit to onwards, here it is related to electrical machines. Electrical machines, which includes transformers. Transformers. In the transformers, we are going to discuss about the principal operation. How this transformer step up and step down the voltages. And construction details. If you open the transformer, you can find the winding, primary winding and secondary winding, some core of the transformer. All those things we are going to discuss in detail about the construction. Next, ideal transformer. So there are some properties of ideal transformer. We are going to discuss about those ideal characteristics of the transformer. Next, what is a practical transformer? And what are the different losses which occurs in the transformer? And what are the different tests which are conducted on the transformer? The purpose of these tests is transformer test. There are two types of the test. One is open circuit test, another one is short circuit test. The purpose of these two tests is to find the efficiency and the regulation. Once if you know efficiency, you can estimate the performance of a transformer. So all these things should be, all the above topics are only elementary treatment, only simple basics. Don't worry, the syllabus is very simple. Okay, it is not so much of difficulty, very, all basic concepts are there in transformer. This is starting it. Okay, these are the 3 units. And let us discuss about fourth and fourth unit is DC machines. Let's say that these DC machines are again two types. One is generators, another one is motors. In power plants, like in Nagarjuna Sagar, you can see the generators, which is used to generate the electrical energy. Electrical energy from the mechanical energy. From the mechanical energy. The purpose of generator is to convert mechanical energy into electrical energy. Okay. And can you guess what is the motor? Anybody can guess? Please respond. Whether it is correct or not, should respond. Shravan? Are you there?
Yes, sir.
Yeah, can you guess what do you mean by motor? I have already given the definition for a generator, which can convert mechanical energy into electrical energy. Based on this, you can.
It's a motor, reverse
Which
of generator. which
Yeah,
converts,
because
which takes electrical energy and converts into mechanical energy.
very good. So which can convert electrical energy into
Electrical into mechanical.
mechanical energy. Best example is Phantom. Okay, na? Once it convert electrical energy by using the wings, we are getting wind energy. And another best example, in every house you can find the motor for pumping the water. Okay, na? It will also convert electrical to mechanical. So unit, in this unit, we are going to discuss in detail about these generators. So DC generator means which can generate only DC supply. In that we are going to discuss about principal operation, how it is converting, how the generator is converting particular mechanical energy into electrical energy. On which principle it is converting. The main basic principle is Faraday's laws. Faraday's laws of electromagnetic induction. You might have studied about the Faraday's laws of electromagnetic induction. Can anybody state Faraday's laws? Do you have the concepts of these Faraday's laws in physics? In intermediate, first year physics? Yes or no? Please respond. Response is very much important. అది మీకు తెలుస్తుందా లేదా అని కాదు కానీ సార్ అట్లీస్ట్ ట్రై టు రీకలెక్ట్ దోస్ బేసిక్స్. అందుకని చెప్పాను కదా మీకు ప్రీ రిక్వైజైట్స్ అంటే ఏం చెప్పాను, మ్యాథమెటిక్స్ అండ్ ఫిజిక్స్ అని చెప్పాను. 157, please respond. 157, 157. Do you have these concepts in first year physics or intermediate physics? Please say yes or no. CR, are you there, Amma?
Yes, sir.
Did you study about these Faraday's laws? Yes or no? Just
Yes, sir. We have studied in 10th standard.
10th standard. Okay, right. Yeah, this generator works on the principles of Faraday's laws of electromagnetic induction. Based on that principle, it is working. And types of DC generators. What are the types of DC generators? EMF equation of the generator. Very, very simple concept, only 4 concepts. If any student want to pass at least pass the examination, this unit is very, very simple. Operation or EMF equation or types, only 3 concepts. Okay. Next mission is DC motor. Again, in this also, principal operation of DC motors, types of DC motors. Here the torque equation, because mechanical energy, no? It is giving mechanical energy. Torque equation. So torque equation you have to derive. Here EMF equation, phi Zn by 60 into P by EMF equation. So I will derive this equation. It is very, very important. So fourth thing, it is very, very simple. Somewhat theoretical concepts, construction and operation. Theoretical concepts in fourth unit. Last unit is basic instruments. Instruments means these are the devices which are used to measure the current, voltage. Voltage and current. Can anybody guess Which type of the meter is used for measuring the voltage? That is voltmeter. Yeah, can anybody guess which type of the meter can be used for measuring the current?
Ammeter.
Very good. In this unit, we are going to discuss about operation. How this voltmeter measures the voltage, how this ammeter measures the current. What is the basic principles, operating principles involved in that meters, and what are the essential features of these instruments, okay, and what are the types of those instruments, and what is the moving coil permanent magnet. Shortly it is known as PMMC meter. PMMC meter or instrument. Another one is moving iron of ammeter and voltmeter. Completed. Only elementary treatment, only basics, not in detail, only basics. Okay. So very simple unit. Compulsory you will get a question on either moving coil PMMC, either PMMC or this is known as MI. Two questions. And another question is essential features. Only three questions are there, important questions. So our syllabus is very simple, very elementary syllabus, very basic one. So the subject is very simple. Once if you follow the classes, it is very simple. If you won't follow and if you won't listen, the subject is very much difficult. Okay? So this is about the introduction to the syllabus. And textbook, which I can suggest you that Basic Electrical Engineering by P.K. Nagsarkar and M.S. Rikisai. Okay? And another one is, I will share another, wait for 1 minute. Yeah. I have the soft copy of this one. This is also a very good book. D.P. Kotari and I.Z. Nagaraj. So after completion of this class, I will post this soft copy.